So this special case here talks about two objects sticking together after a collision. And so what that means is that the final speed of both objects is the same. So some people would write that speed one way, and then I guess I would say there's just two ways of sort of setting this up. So of course we'd want to make some sort of statement saying that momentum is conserved. And then one way to set this up is to say 1,000 kilograms times 25 meters per second plus 600 times, and then also I'm going to put a negative in here. That is because this object's going to the west. Okay, so that would be the total momentum before the collision. And then I think most people would probably say, well, they're sticking together. So let's add the masses together and say 1,600 times some unknown v, and you could find your speed that way. Another way of setting it up is, again, to sort of leave this part the same, but on the right-hand side, some people just prefer to take an extra step and say that both objects have the same speed, and so they just use the same variable for both of the v's. Again, either setup is fine. Another special case to be aware of is when there's some sort of an explosion or separation. And sometimes these sorts of problems throw people off. They don't know quite how to set them up. But the key idea is that the initial momentum is actually 0 before the separation or before the explosion. So this whole side of the equation is 0. And then the other side of the equation, we have a 10 kilogram cart that's moving at some unknown speed that's what we're trying to find. And then we have the 6 kilogram cart traveling at 5. And so when we go through and do the algebra here, we find that the velocity of the 10 kilogram cart is 3, but it's 3 backwards, because this comes out to be -3. And again, that should kind of make sense. That the object moves to the left, since the other object moved to the right. You know, we wouldn't expect them to both go in the same direction when the spring was released. So anyways, this is a good method of setting up that sort of a problem that illustrates your understanding of momentum conservation.